Nonmetals have two ways of becoming stable. One is for a nonmetal atom to gain electrons to form an anion and then participate in ionic bonding. And the other is for a nonmetal atom to share electrons. And when they do this and the overall charge is zero, we call those covalent compounds. Covalent compounds are formed by nonmetals and metalloids sharing electrons. The first step in naming is to recognize that it's a covalent compound. It's covalent if it doesn't begin with a metal, which forms metal ions, or this one nonmetal ion called ammonium ion. Ammonium ion is an ion that participates in ionic bonding. And the second step is to classify it, and here are our categories. There are some common names that you know, or maybe you'll learn. There are hydrogen-containing gases. There are only 6. And then compounds that begin with an H and participate, are bubbled through water and behave as acids, are named as acids. And finally, there's the molecules that don't fall into the previous categories. And we name those by saying how many of each kind. So the common names, the first one, you're familiar with, water. The second one, you probably are too. Ammonia is important in our everyday lives, and it is also a weak base that you're going to need throughout this semester and in general chemistry. It is not to be confused with ammonium ion, which looks very similar and is related, but does not behave as a base. If you're a person who makes flashcards to learn things, this might be a good combination to focus on ammonia and ammonium ion. The next one, methane, you may be familiar with. In chemistry, methane is what we use for lab gas. So when we light a Bunsen burner, we're burning methane. But also, cows produce methane. And you know that cows have 4 legs. So maybe that'll help you memorize the formula for methane. Now, the next 2 you may not know, and you may not need for general chemistry. It depends on who your next instructor is, but you might hear about them on the news. So this is phosphine. Phosphine is a gas, and it has an unusual odor, and it's poisonous, and it's flammable. And it is produced as a byproduct in the manufacture of methamphetamine. So if you're a fan of Breaking Bad, you may have heard Walter White and Jesse talking about phosphine. This is why they wore the respirators, because they didn't want to breathe this. And on the news, you may hear about a methane bust, methamphetamine bust. Somewhere, a house exploded or people were killed because they were breathing this poisonous gas. So that's one you may hear about on the news. And then the next one that you may hear about on the news is hydrazine. And hydrazine is used as rocket fuel. So these are the 5 common names that you need to know. And notice that they all have hydrogen. Okay, this next list of 6 are 6 compounds that are covalent that can be pure. So here we have hydrogen fluoride as a pure gas, or could be bubbled through water to make an acid. So this list of 6 has 2 names, depending on is it pure, a gas, or has hydrofluoric acid been bubbled through water and now it makes an aqueous mixture. And this aqueous mixture would be a solution. In this context, hydrogen fluoride has changed its name to hydrofluoric acid. And the reason it's named as an acid is because it behaves as an acid. So, these hydrogen-containing gases, if they are pure, have a name that just is hydrogen something-ide. Hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide, hydrogen sulfide. We don't mention that there's two hydrogens. And hydrogen cyanide. But if they're bubbled through water, then they have a name as an acid. So there's three kinds of acids. There's going to be the kind that have no oxygens. And then there's going to be two flavors that do have oxygen that we'll see on the next slide. So when hydrofluoric acid is a mixture in water, when hydrogen fluoride is mixed with water, that solution is called hydrofluoric acid. And if you've seen Breaking Bad, you understand that hydrofluoric acid is super powerful. It will dissolve, eat through, react with almost anything. Okay, so those six have a second set of names. Hydroic acids. If an acid does have an oxygen, it wasn't made from an ide, it was made from an ate or an ite. So for anions, negatively charged ions, we might have an ide, fluoride, and ides make hydroic acids. And there's a mnemonic for that. Myride has hydraulics. So the hydro goes with the ide. But other acids with oxygens, for example, you might have an oxygen made from an ate. This is nitrate. It's a polyatomic ion that you'll need to become familiar with. Or it could be made from an ite. This is nitrite. Those don't have a hydro. Ates make ic acids. So if we add enough hydrogen ions to nitrite, we have a -1 charge here, +1 charge there. We can form a compound that behaves as an acid. And ates make ic acids. This is nitric acid. Or if that anion containing oxygen is an ite, and we add enough hydrogen ions so that there is no overall charge and it's a compound, that is nitrous acid, us-ite. And here's your mnemonic for memorizing that. Ick, I ate a poisonous bite. Ates make ick acids. Ites make us acids. So if you recognize that something is a covalent compound and it doesn't have a common name or begin with hydrogen, then we say how many of each kind. And to do that, we use Greek prefixes. So here we have monobromine, and then 3 triiodide. Except if the first element, oops, I spelled that wrong. Triiodide. The first element is given the elemental name. The second element is given, the name has been changed to an ide, so the N has been replaced with a D. And then for the first one, if there's only one, we just say bromine. We don't say monobromine. So this is bromine triiodide. The next one, we have 2 nitrogens, so di, element name, space, and 4 oxygens, tetra, oxide. But if the prefix ends with an A or an O, And the first letter of the element begins with an A. Oops. Begins with an A or an O. We don't use the prefixes last A or O. So this is dinitrogen tetroxide. It's just easier to say. But notice that the prefix ending in I and the next one starting with an I, we didn't cancel an I. Triiodide. I don't know why. Okay, so here we have one carbon, but we don't use mono for the first one. So say the element name. And then we have one oxygen. We do use mono for the second one. But I'm not going to say monooxide because we're not going to use this O. We're going to say monoxide, carbon monoxide. Two phosphoruses. When you're spelling, phosphorus ends with a US, unless you're in Europe. And then 5 oxygens would be penta, except we just say pent oxide. Element name, and then the name has changed from oxygen to oxide. 4 phosphoruses, tetra. Dec oxide. Okay, the last one is an example of, this is a covalent compound, even though that's not a non-metal. Boron is a metalloid. Boron trifluoride. The trick is to recognize if it's covalent. So to classify it as either covalent or ionic. And then if it's a covalent compound, further classify it. So here we have something that begins with boron, which is a metalloid. If there's a metal, it will always be on the left. So boron's a metalloid, and there's no hydrogens here, and I don't recognize a common name. So I'm going to name that as a covalent compound. Boron tribromide. The next one is not a covalent compound because aluminum is a main group metal. Aluminum loses electrons like metals do, and its main group, so it always has a fixed charge. So aluminum loses 3 electrons to be isoelectronic with neon, the nearest noble gas. And then 3 chlorides were required because chloride is a halogen. And when it gains electrons, it becomes a halide with a -1 charge. So we needed 1 aluminum and 3 chlorides to have the overall charge be 0 so that it's a compound. So let's name this ionic compound because it always, as an ion, has a +3 charge. We don't state the charge. So this is just aluminum chloride. The next one is a covalent compound. Nitrogen and oxygen are both nonmetals. Nitrogen, element name. Don't use mono for the first one. And dioxide. Oxygen becomes oxide because it's the second one. Okay, here we have something. It is covalent, but it is not a compound. To be a compound, it would have to have more than one element, more than one capital. This we recognize is one of our 7 diatomic elements. This is nitrogen. Here we have a covalent compound because hydrogen, even though it looks like it is an alkali metal, it is not a metal. Hydrogen is to the left of that stair-step line. It is the only nonmetal to the left. So this is covalent, also covalent, also covalent. Okay, so hydrogen fluoride is pure, and it's a gas, one of 6. But if it is bubbled through water, it behaves as an acid, and we name it as an acid. Hydrofluoric acid. Hydroic acids come from ides. The last one you'll recognize has a common name, and that's water. You would never call this dihydrogen monoxide, because that's not its proper name. But DHMO, dihydrogen monoxide, is used at a spoof site called dhmo.org. And so I'm telling you now, this is a spoof. These are people who are using the fact that we don't understand. We get scared by chemical terms. Yes, water technically is a chemical. Is it dangerous? It can be, but not usually. So at this spoof site, they make statements that are actually quite true, but they frame it in a scary context. And actually, one town banned DHMO from their town because it was so frightening what they had read at the site. So here's an extra credit opportunity for you. If you want to go to dhmo.org, and this will be an extra credit opportunity, 2 points for exam 2. If you want to go there and just see some of the true statements that are framed in a frightening way, and then pick one that you find amusing and either type up or write up a short paper, kind of like we did for the chemical symbols that don't come from the English language. That was last week's extra credit opportunity. If you want to do that and submit it, that would be great. Okay. Thank you so much for your time.